Now we want to focus on developing countries because that is where the growth is going to be coming from. Right? So if you look at the OECD countries, that's the blue bar. This is from EIA. This is the projection and of where the growth in demand is going to be. Right? And what you see here is the blue countries, the OECD countries, is largely plateaued. Right? There's not going to be any growth in energy consumption, where the energy consumption growth is going to be coming from primarily non-OECD Asia. So that is China, India, and Indonesia. Emerging markets, right? And that's where most of the growth is coming from, right? And also you have the other non-OECD countries that's also growing faster than OECD countries. All right, so right now you have a lot of population, a lot of these countries that are currently using biomass, and they will be uh, um, changing their fuel source, right? As their economy becomes more developed. Okay. All right. Now, so for us to begin, kind of think about energy, we need to talk about just a few concepts here. These are all very simple. They're all very simple and they're all very obvious. So first one, net energy. All right, so net energy is simply a calculation, energy made minus energy required to produce it. Okay. And of course, you want net energy to be as high as possible. All right, but if you want to compare between different energy sources, net energy ratio is much better, right? Because now you can use so you take energy available, basically energy made, right? Energy made divided by energy required to produce it. So this tells you for every for every like say joule, right? So for every joule that you input, right, how much more joule are you getting back, right? So okay, and when countries or when society chooses energy, right, they're going to choose ones with the highest net energy ratio. Okay, here let's actually take a look at this here. So here is just for reference so the net energy ratio for various energy sources. Now these estimates are pretty old and they can change pretty significantly over time as technology changes, right? So take these with a grain of salt. Like for example, natural gas, right? So this chart, this table is probably 8 years old. If you look at natural gas today, the net energy ratio is going to be much higher, right? That is because natural gas turbine are much more efficient, and because of fracking, natural gas is much cheaper or less. It is much more efficient to gain natural gas. Right? So that number is going to go up. Okay, shale oil will also increase, so this number expect that to go up dramatically as well. But overall, right, this gives us an idea why fuel source such as oil and coal are so popular compared to, let's say, solar panels or wind. Right, they have very high net energy ratio. Okay, let's go back to this a second here. Now, of course, net energy ratio is not the only thing that we think about when we make energy choices. Suitability also matters a lot, right? Nuclear power might have a very high net energy ratio, but it's not very good for automobile. Okay, so suitability, how trans different applications. So oil is not going to be replaced anytime soon by either coal, natural gas, or nuclear power because it's just not very suitable. Right now, for availability now. Not so much location. This has to do with more physical reserve, like how much of it do we have left in the world? Because transportation of these fossil fuels are pretty efficient now. Now, availability become more of a constraint when we talk about renewable energy, so geographic and seasonal constraint. You might get a lot of sunlight in California and Arizona, but you can't export that sunlight to let's say Washington or Canada. Right? Now, prices are going to be the primary factor of energy choice, right? Most so we simply choose the lowest, simply choose most investment is going to depending on how expensive, how costly these energy sources is. Now, when you look at prices, you look at average price, which is important, but also volatility, meaning variations over time. Right? If a particular fuel source has too much volatility, then that is a bad investment. Right? Right. And so when you think about what is the barrier to renewable energy, for example, right? You want to think about how volatile is the cost, either in the installation, financing, or the subsidy or the policies. If it's very volatile, then that will influence people's decision to make that investment. Then the last factor, unfortunately, the last factor is the environmental impact. When you look at energy, it obviously particularly fossil fuel, has a lot of negative consequences, environmentally speaking. However, in the decision making process, when nations choose to use the particular energy source, this is typically the last consideration. All right, so let's now talk about availability, meaning how much fossil fuel do we really have? Can we rely on fossil fuel energy forever?